Alright gang, we're going to do the graph of cosecant pi x. So the reciprocal of this, using the reciprocal identity, is 1 over sine pi x. So what you actually want to graph first is the reciprocal, which is sine pi x. So that's why I have the standard table here for pi. I'm going to convert this table for sine pi x. Now, since there's nothing outside the trig function, the y values do not change, right? There's nothing outside, so these values stay the same. All right, but there is a pi for the b, so that's going to alter the domain. So I'm just plugging it into the formula as you've seen me do. Alright, which means the period of 2 is 2. So instead of the period being 2 pi or like 6, it's a third of that. It's going to be 2. Alright, so the formula for the increment is period over 4. So we're going to put 2 over 4, we're going to reduce that to 1/2. This graph is not shifted left or right, so the old start is the same as the new start because there's no c value here. Alright, now I'm just going to keep adding the increment to get to the next one. You can also, since you know it's 2, you know it goes from 0 to 2, and you can just cut it up that way as well, which is easier, but I'll just follow this because this always works. And when you're first learning, it makes students feel a little more confident if you give them something that always applies. Okay, but again, you could have, since it started at 0 and it has a width of 2, you would have known it ended at 2. Halfway between 0 and 2 is 1. Halfway between 0 and 1 is 1/2. Halfway between 1 and 2 is 3/2. You could have figured it out that way. You didn't need to to crunch this part out. Alright, so that's it. I'm going to graph this function first. So let me get a piece of paper for that. So you always have that moment where you're like, oh, how do I scale this? How big do my nicks need to be? That kind of idea. So, I mean, all these numbers are really tiny. So when I draw my nicks, I'm going to make them quite large. So if I call this 1/2, when you're scaling the range, I mean, you've got 1 is like now this distance, right? And then you're going to want to pull it out a little bit more. Right, so that you have 2 periods of this function. Alright, so now I'm going to go ahead and you're going to see me transfer the coordinates. So 0, 0, 1/2, 1, 1, 0, 3/2, -1, 2, 0. Right, so that's one cycle. Now you're gonna now I'm gonna repeat it. Okay, so if this is down middle, then it goes up, then it goes middle, then it goes down, then it goes middle. Okay, so we're just repeating it. Alright, so what I have here in the pencil is the sine pi x graph, but what we came here to do was the cosecant. So the cosecant is the reciprocal, which means as one gets smaller, the other one gets larger, right? They go opposite. So the first thing you want to do is the cosecant has an infinite amount of asymptotes, and the asymptotes will always go through the center point. Now I'm being really specific here because some people think it always goes through the x-axis. That's not accurate, okay? That's not accurate. What it does is it goes through the center point. So the middle, whatever would be like the middle of the graph, that's what it will go through. Okay, so there are my vertical asymptotes. Now the function is going to be equivalent. So like when the this function equals to 1, its reciprocal is also going to equal to 1. So it's going to connect at all the hills and valleys. Okay, but then you have to remember they're reciprocal. So as one gets smaller, the other one gets larger. Right, as this gets smaller, the other one gets larger. So what happens is that the amplitude of the reciprocal pushes the parabolas far enough away from the axis so that you get the correct, like, sort of height up and down. And then the vertical asymptotes help you get the correct width of the parabola. So not only do they get pushed up and pushed down to the correct position, they also get squeezed into the correct mold with the VAs. Remember that one cycle is one parabola up, one parabola down. So I've drawn 2 cycles here because I have 2 sets of that. And technically this other one is not like part of the final picture. Right, that we were just using as like a tool to sketch the cosecant function. So the final function is really just an infinite amount of these floating parabolas, okay? And that's the final answer, gang. Catch you. Bye-bye.